Good morning, and today we're going to be looking at something called the section formula, but I'm also going to show you a common sense approach to this. This is to help you to find coordinates in between coordinates that are given, or perhaps coordinates on endpoints. Now I'm first going to make reference to something that's done within the circle topic, but please do not worry if you haven't actually covered the circle topic yet, because this is just a common sense approach, something called the stepping out approach that I'm going to show you. So let me just show you this question in context of the circle, and then we'll go on to some vectors questions. This circle has centre S, which is -2, 0. If the coordinates of T are 2, -2, find the coordinates of R. So you can see here that we've been given the centre and we've been given T. Now we know that the centre is right in the middle of this circle, so the gap from here to here is exactly the same as the gap from here to here, and that's how we're going to use this method called the stepping out approach. So here we have just the line that's there. The fact that it's in the centre means that that line is right in the middle of R and T. That centre is right in the middle of R and T. Okay, now if you look at your two x values from here to here, we can see that there's a gap of 4 along the x-axis, okay? And if we look at our two y values, from here to here, we can see that there's a gap of 2 along the y-axis. So exactly the same pattern will occur to go from there to there. So along the x numbers, you'll go back a further 4 and you'll go up a further 2. So to find your new x coordinate, you look at the x values and compare them. To go from 2 to -2, we're going back 4, which is like taking away 4. So if we start at 2 and take away 4, we get to -2. We take away a further 4 and we will get to the coordinate of R, which is -6. We do the same with the y's. We start at -2 and we go down 2 to get to up 2 to get to 0. So we're going to go up a further 2 and that will take us to 2. So whatever we do from here to here, we do the same again to get to here. And that's called the stepping out approach. And that allows you to see that R has the coordinate -6 and 2. Okay, I'm going to show you the section formula. Section formula can be used to divide a line into a given ratio. So this is particularly useful when we're not just looking for midpoints. It's much easier when it's a midpoint or an end point given a midpoint, but it's much harder when it's in a different type of ratio. Now to begin with, I'm going to use letters for the ratio, and then I'll show you with numbers, and you'll see how simple it gets when we start to put numbers into it. If the point P divides the line A and B in the ratio m to n, that means that the point P divides A and B in the ratio m parts to n parts, m to n. Now these letters m and n will usually represent numbers. Now this looks quite complicated, but it's quite simple when you actually start to do it with numbers. So you add your two ratio numbers together, and then it's 1 over the sum of those two numbers. And then it's n times the position vector A and m times the position vector B. So we will create position vectors from our coordinates A and B. Now notice, I think this is the opposite of what you would maybe think. So notice that the m goes with the B and the n goes with the A. Okay, so let's put it into practice. So here we have two coordinates, A and B. Find the coordinate of the point P that divides A and B in the ratio 1 to 3. So using the section formula, using that formula there, what that means when you put the numbers into it, you don't have to write that formula out when you do the questions. You can just go straight to the numbers. Okay, so for our diagram, it is useful to draw the diagram with your letters, your point in between those letters, and the numbers in the order. So if P divides A and B in the ratio 1 to 3, in that order, there's your A and B, there's P, and there's 1 to 3. So that means that that's 1 part along and 3 parts along. So there's 4 parts altogether. So the first part of this is going to be these two added together, which becomes the denominator. So it's 1/4 of 3 times position vector A plus 1 time position vector B. Remember, you get your position vectors from using the coordinates. The coordinate of A is 4, 3, so position vector A will be 4, 3 written as a column vector. Okay, and it's 1 times position vector B, so there's nothing in front of that position vector because it's just a 1 times that. Now, you will then multiply all your numbers together. 3 times your 4, 3 times your 3. Then add those together. 20 plus 8, 9 plus 15. And the numbers pretty much usually work out to be numbers that work out well. They divide well. So 1/4 of 20, 1/4 of 24. But if they didn't, you would just leave them as fractions. So we have the position vector P as 5, 6 written as a column vector. That means that the coordinate P would be 5, 6 written as a coordinate. Okay? And that's how you would do that. Now I'm going to show you a common sense approach to exactly the same question. This is using the stepping out method. If you prefer not to have formula, but to have a kind of more common sense method to do something, then pay attention to this one. You can decide which method you're going to use, either using the section formula or using this method, and pretty much stick to one or the other, okay? Okay, so looking at this, the diagram again helps you to see that we've got one part here and 3 parts here, so we've got 4 sections altogether. Now that means that point P is actually 1/4 of the way along. If these are all split into 4 parts, that's 1/4 of the way along from A to B. To find the x point, you look at the difference between your two x numbers from 4 to 8. So there's a gap of 4 there. 8 take away 4 is 4. Okay. So that there represents in x's a gap of 4. 1/4 of 4 is 1. So every one little part in terms of the x numbers will stand for 1. Now you look to see which x number you started on here. We've started on the x value of 4. So we will add 1 to that and get to 5. So that gives us the x coordinate 5. Let's do the same with the y. Okay, what's the gap between the two y numbers? So we're looking at the 3 and the 15 here. So 15 take away 3 is 12. So we've got a big gap of 12. Now that means then that we're going to find 1/4, because there's 4 parts, 1/4 of 12. 1/4 of 12 is 3. So in terms of the y's, every little part stands for a 3. So what y do we start on here? We start on the 3. And we're going 1, 3 further along. So 3 plus 3 is 6. So that also gives us the coordinate 5, 6. Okay. So 2 methods to find the points. This one here I think is particularly good if it's an end point that you're finding and not one that's somewhere in the middle. So whatever you do from there to there, you can see that you do 3 times more to go from there to there and so on. So that one is particularly good. But you can use your section formula for that just the same. Okay. So we're going to be looking at exercise 13K. We'll do questions 1 to 4 and question 6. And there is a note here. There's a typo in the textbook. So change R to 29 for question 4. Now message your teachers if you have any problems, any questions. And as always, send in a photo of your marked work. And just ask for help if you need it. Okay, good luck and take care. Bye-bye.